So it's for me, Tim Steffen, Senior Director of Product Marketing for vSphere. I've been with VMware about 4 years, and it's been quite a ride. The one thing I will say with everyone here, we at VMware want to make sure that you guys get everything you need to out of this conference. So if you see any of us with the vSphere or VMware badge, grab us, ask us any questions, because we do want to make sure that you are getting all your questions answered, getting the product information you need. So feel free to get in touch with us at any time. And as for me, I'll be at the booth tonight. So if you see anything in the presentation today, I'd be glad to answer any questions. So what are we doing here today? The disclaimer slide. This is a very introductory session. So I'm going to take you through who VMware is, what virtualization is, how it can benefit you, and then by that time you're going to be really excited and want to start off on your virtualization journey. So I'm going to tell you how to get started very easily and effectively. As for who the target audience for this session is, I don't want to say it's my mom, but it's pretty close. She doesn't quite have that copy, cut, paste thing down yet. How can the file be in two places at once? I got her a digital phone actually recently, and she moves the pictures to the computer, but then prints them out and deletes the file because she's got the photo. Why does she need the file anymore? So that's not quite the level of this presentation, but it's pretty close. So if you know what a hypervisor is, you might be too advanced, but what I'm trying to do is get you guys prepared so that all the other sessions, all the announcements that we're making tomorrow are going to make sense. So you'll see where we're taking virtualization. This presentation is going to take you to where we are today. So who is VMware and what are we trying to solve? Well, VMware actually started as a grad school project at Stanford University. And it was just purely theoretical. We saw, I obviously was not there at that time, but the founders saw that IBM had virtualized the mainframes back in the 70s, actually, and that there were a number of x86 servers out there all hopelessly underutilized. Like 8 to 10% of these great big machines were being utilized. So they wanted to see, can we actually virtualize the hardware? Can we make it stable enough, secure enough, and performant enough to actually run applications, but in a virtual environment? And what's interesting is this lab project actually kicked off the same time as Google did. So Google was in the next room, and VMware was over here, and they'd trade ideas and beta each other's projects, and it was kind of a pretty interesting time. So from that humble beginnings, and back then VMware was called Project Disco, so I'm glad we changed the name. We've now grown to become one of the largest software companies that people really haven't heard of, right? Because unless you're in the data center or unless you're looking at cloud computing very directly, no one really knows that much about us, unless you have a Mac and you run Windows on your Mac, and then you might know about Fusion. But unless you're in the data center, you don't know. But we've grown to $2 billion in revenue. We've got 190,000 customers now, 100% of the Fortune 100, 100% of the Global 100, 96% of the Fortune 1000. And actually last year, our COO, Todd Nielsen, issued a challenge to all the attendees to say we need 100% of the Fortune 1000, and he was giving people a free pass to VMworld if they were able to bring in one of those accounts. So I don't know, maybe that's gone up or not. The one thing that really surprised me, too, is of that 190,000 customers, 150,000 of them are small and medium businesses. So a lot of people think of VMware maybe as the Oracle or the enterprise company, whereas others might be in the SMB. We've got a lot of small businesses that are adopting virtualization and adopting it very, very quickly. So VMware, we grew from humble beginnings to become the major player in virtualization software. As Gartner says, 84% of current virtualized applications run on VMware. And of course, that's 2009, so it may have changed a little bit. Global partner ecosystem. 1,300 technology and consulting partners, all the big names there. And as we move to cloud computing, we've already got 1,700 vCloud service provider partners. And now I'm jumping ahead a little bit in our technology roadmap, but that means that there are 1,700 partners that have decided to build cloud service platforms on top of our virtualization technology. So if an organization wants to adopt virtualization in their internal data center, and then migrate some of those applications or blend their internal data center with services from an external cloud provider, there's a lot of selection. There's a lot of choice of providers to go with. And some of those are up and running already, and you'll see demos of those tomorrow during the keynote. It should be pretty interesting. VMware delivers the most proven, reliable hypervisor, so our products are proven. On the left there, proven by customers. our customers are kind of interesting. They like to tweak our software and get the most mileage, so to speak, like Prius drivers who add extra batteries and get 100 miles per gallon and then brag about it to all their other Prius driver friends on the internet. Well, people send us screenshots of their management application and brag about the amount of performance they're getting from VMware. So this guy sent in a screenshot, and he had 1,500 days of uptime for one application. So obviously they missed a patch or two somewhere along the lines, but this is the way they chose to run their data center. So they brag about the uptime. Actually, one guy came to the booth one time and talked about VMware as the Viagra of his data center. I have no idea what he's talking about, and I walked away pretty quickly after that. Redmond Magazine, which is kind of interesting, so we get some external accolades for our software. The 2008 Editor's Choice Awards, VMware ESX, our hypervisor, was named the most reliable piece of technology in the planet, according to them, according to their readers, right? And their readers are the Microsoft community. It's the independent voice of the Microsoft community. So that was kind of a nice award for us to win. And I'll also beat the IBM mainframe, which is known as the bedrock of stability in all of IT. So we're getting recognized as having a proven product. Even Gartner, they came out with their first ever virtualization Magic Quadrant last year, or this year actually, and VMware was the only leader. So we were the ones with the vision and the ability to execute. So that was nice to see as well. But the point of showing all these slides here, it's saying we're big, we're successful, we've got a lot of partners, and we're getting accolades. It's not to beat our chests up here and say, look how great we are. The point is that when you adopt VMware's virtualization technology, we can assure you of three things. One, that it's proven in the most technically demanding data centers, the largest environments and the smallest environments. So it's proven software that you're going to find that's going to work. Two, we're a larger company that's going to be around, so your investment is future-proofed. We're not going to be gone in 3 years, and then you're going to have to figure out another investment to make in someone else's virtualization technology. And three, because of our partner network, your existing technology, your existing applications, your existing hardware, and your existing peripherals will all work in the VMware environment. So we're going to be around, the software is proven, and you're going to be able to leverage your existing investments. So given that, what are we trying to solve, right? Well, what's the existing landscape look like? Well, today's IT environment is, as you guys all know, it's complex, it's inefficient, it's not very flexible, right? It's very static. You get it to work, and you don't want to touch it because you change something, and it might not work anymore. And then you'll have to go figure out exactly what caused it to break. We're finding from our customers that around 70% of their IT budgets are on just maintaining the status quo. And technology is one of those things that's actually improving competitive advantage among a lot of organizations, but they don't have any budget or time to spend on improving their technology because they're spending so much effort just to keep the lights on. So we're trying to figure out a way to reduce the complexity, reduce the inefficiency, and make things much more flexible so that people are spending less time on just keeping the lights on and more time on strategic projects that are going to make their company more competitive in their market. I mean, for example, here's some statistics before VMware. 36 million servers, a tenfold increase over 15 years. That's a huge growth in the number of servers, and each one of those servers needs to be maintained, sucks a lot of power, and costs a lot of money in capital expenses. And each one is probably used in a physical environment at 8 to 10% of its capacity. So there's a huge amount of unused, untapped capacity in the data centers. Power and cooling, as you guys probably know, it's a huge expense for every organization. People are building data centers next to dams to try to reduce the amount of expense just on electricity. We had customers that before they virtualized, they had diesel generators out in their front yards just to get the power. It's not only about the expense of electricity now, it's just having enough electricity available to power your data center. Space, you need a secure, efficient data center building in order to house all this IT equipment, and that's costing more and more. And then the operating costs, $8 in maintenance for every $1 in infrastructure. It's just very expensive, very inflexible, and not the way that people want to move forward. So how do we move forward? Well, obviously something isn't working very well, so what do we do about this? And that's actually a shot of a Microsoft Azure data center. I'm just kidding, sorry. Sorry. You'll probably hear a few digs here and then. So our mission is your mission, right? And it's very simply stated. Reduce the complexity, dramatically lower costs, and enable a flexible, agile IT service delivery. Now, it's very simply stated, but we have invested a lot of time, 10 years already. I can't believe we've been around that long. 10 years, millions of dollars, thousands, tens of thousands of engineering hours in developing a solution that will fix these issues in the current IT environment. So what exactly is virtualization then, and how is it going to help? How has it made us successful, and how will it help solve these problems that are plaguing everyone's IT environment? Well, let's just read along on this one, because I don't know how better to state it. The x86 computer hardware was designed to run a single operating system in a single application. Right? So that resulted in vastly underutilized servers. As I said, about 8 to 10% of a server's capacity was utilized because you could only run one application and one operating system effectively on a single server in a physical environment. Well, in the virtual environment, you can run multiple applications with multiple operating systems, each encapsulated in a virtual server, or what we call a virtual machine. So for those of you that are more visually inclined, because this makes a lot more sense to me, on the left is what it used to be. One application, one operating system. On the right is a virtual architecture where you've got VMware. The hypervisor is the communicator between the hardware and all the virtual machines that run on that server. So you've got a lot of encapsulated virtual machines, each with their own application, their own operating system, and you can mix Linux, you can mix Windows, you can mix flavors of Linux, you can mix all different types of applications, and they're all running on a single server, not conflicting with each other, but utilizing the excess resources on a server. So instead of having 8% utilization of a server, you have about 80 to 85% on average utilization of a server. Instead of having 10 servers to run 100 applications, you have, instead of having 100 servers to run 100 applications, you have 10 servers to run that applications. It's less to maintain, less power, less capital expenditures, and a much more condensed, efficient data center. And that's just the beginning. So how did we get here? Our first hypervisor was GSX, and that's what we called a hosted hypervisor. And that ran on top of an operating system. So you had a server that had Windows or Linux on it, and then you put the hypervisor on top of that operating system just as you would any other application. And then you ran the virtual machines on top of that. So that was the first innovation. Obviously, there are some inefficiencies there because the operating system is taking up a lot of resources. The operating system is subject to patches and bugs and security breaches that would affect every virtual machine running on top of that operating system. So we had to develop what we called a bare metal hypervisor. Wow, that's some graphics there. I should have given you guys 3D glasses or something. We have VMware ESX, which came out in 2003, and that was first what we called a bare metal hypervisor, which meant there was no operating system in between the hypervisor, or the communicator, and the hardware. So the VMware ESX was less subject to an operating system, although it still did have a service console, which was a variation of Linux. So it's very stable. It's what a lot of our customers use right now. Probably 75 to 80% of our customers are enjoying the benefits of ESX in their data center right now. But we wanted to get rid of that blue box there, the service console, because we wanted to remove any dependence for the hypervisor on a general purpose operating system. So we launched VMware ESXi in 2007, and this is as bare metal as it gets. When we first launched it, it was about 64 megabytes in size. So that's all you put, that thin layer on top of the hardware, and then you run virtual machines on top of that. There's no service console. There's no general purpose operating system. The small code base means fewer patches, less security impact, and a better performing infrastructure because nothing's going to affect the hypervisor, so the virtual machines on top of the hypervisor are not subject to any deficiencies in that hypervisor. Now, with our most recent release of vSphere 4.1, which came out in July, that is the last release that's going to have ESX and ESXi. So all our customers that currently run ESX would now have to migrate to the ESXi architecture. So those of you that are just starting with virtualization, I would recommend that you work with ESXi. And we can talk more about the differences. But that's the evolution, right? This is how virtualization started. You get a hypervisor in between the virtual machines and the hardware, and that enables you to encapsulate and isolate all the virtual machines and the applications on a specific server. So what are the key properties of a virtual machine? One is partitioning. And we talked about this one right here because it's very important as far as initial cost savings and server consolidation. You can run multiple operating systems on one physical machine. You divide all the physical resources between virtual machines, but those resources do not conflict, or the applications that are on the server do not interact with each other unless you want them to via a network switch. So you can partition, and this is where you get a lot of savings because you're consolidating a lot of servers running very few applications into a smaller number of servers running a lot of applications on them. Isolation. That means that every virtual machine on a server, whether you have 2, whether you have 10, some of our customers now with the 8 processor or the 8-core chips that are coming out are actually getting 30 virtual machines on a single server. Each one of those is isolated from all the others. That was always a concern in the early days of virtualization, is how could you break out of a virtual machine and affect all the other applications on that server? Well, no one's done that in production yet. We take great care to make sure that every virtual machine is as isolated as a physical server would be. Now, you can connect them via networking or other connections between the virtual machines, but in its standard state, every virtual machine is completely isolated. Encapsulation. Now, this is really good for backup or snapshots and things like that because the whole virtual machine, the whole application, the whole operating system, whether it be a print server or an entire Exchange database or mailbox infrastructure, is fully in a software form. So you can migrate those files, you can back them up, you can copy and paste them, you can do whatever you would do with a single file or with the entire server, the virtual server. So this makes migrating, creating virtual machines much, much easier than in a physical world. So it cuts down on the operational costs of spinning up servers or creating cloning servers because all you're doing is copying files and then reinstalling them in another virtual machine. Fourth thing is hardware independence. So when you've got a virtual machine on a specific server, it is not tied to the hardware. In fact, as long as the hardware meets the requirements of that virtual machine, it doesn't care what the hardware is. All it cares about is the communication that it's getting from the hypervisor, which is managing the communication between the hardware and the virtual machine. So what this enables you to do is some of the more advanced level features of virtualization. You can actually take a live virtual machine, a live application, and move it from one physical server to another without downtime. So there's no interruption to the end user. They wouldn't even know that the server had changed. So it's completely independent of the hardware. It's a very important step as you move to be building a private cloud or something. In fact, we have other applications or services like Distributed Resource Scheduler, which is DRS for short, actually will load balance your applications across the number of servers in a cluster. So you take a number of physical servers, say 5, create a cluster there, and then as applications demand resources, the DRS application will use vMotion and live migrate those applications to different servers to ensure that you're fully balanced and then to ensure that all the applications are getting the resources they need. Hardware independence, very important. So given that, virtualization is very important. It's a high priority for everybody right now. We're also seeing cloud computing, which you'll hear a lot. I think you'll hear more focus on cloud computing after today than you may on virtualization, because we see cloud computing as the logical extension of virtualization being the foundation to enable cloud computing. This is becoming a high priority for everybody. So why is it such a high priority? Well, because there are a lot of benefits associated with virtualization. It's really where everyone seems to be moving. Most of our customers start out, they virtualize Tier 2 or Tier 3 applications, their test and development environments. They find out it's efficient, it's secure, it's stable, it cuts out a lot of costs, it cuts out a lot of activity that's required in terms of maintenance for every one of their advisors. They can focus more on strategic technology initiatives. So they move from 30 to 60 to 70 to 80. And a lot of our customers now have virtualization first policies, meaning that any new application now goes in a virtual machine rather than on a physical server. There are only few exceptions where people will put applications in a physical server, but those are exceptions now. It's not the standard. Now, the reason people do that is because of all the different benefits that virtualization enables. One is consolidation, as I said. You go from 100 servers running 100 applications to 10 servers running 100 applications, 10 applications on each server. The second benefit here that I'm listing is containment. What you do is, instead of having server sprawl, meaning you buy a new server every time you create another application, your data center grows at an exponential rate because you're building more and more applications and you're basing more and more of your business on technology. This enables you to leverage your existing technology. You just create a new virtual machine, put it in your existing pool of resources, your existing server base, and you don't have to buy new hardware every time you create a new application. And then availability, right? You saw the guy early on who had the 4 years of uptime for a specific application. That's actually now becoming the number one priority for people who start to virtualize, because there are so many benefits to making an application available with virtualization. No longer, if a server goes down, is that application tied to the server. So it used to be a server goes down and your Exchange environment's on that server. You got to get that server back up before the Exchange server will come back up. Now what happens? Server goes down, that application moves to another server that's up in your cluster, and it will have a short amount of downtime, but you'll be up and running within minutes rather than having to come in and fix that physical server before the application will come up. And there are even the functionality I'll talk to later called fault tolerance, where you have a shadow virtual machine that follows the original virtual machine. So if a server were to unexpectedly go down, all of a sudden that shadow virtual machine becomes the primary virtual machine, so you'd have no downtime in the event of a server failure. It's very interesting technology. So people are seeing there are a number of benefits beyond consolidation and containment that enable high availability for your applications that you could not get in a physical environment. Here are some other benefits actually quantified for how much virtualization can help. These are our corporate marketing slides talking, because they're going to be great graphics here. Got the guys from Avatar to make these ones. So financial energy, right? You can do more with less. So your capital costs are reduced 50 to 60%. You delay the data center expansion, so you're not buying more physical hardware every time you need a new application. And your operational costs are reduced by about 25% as well. Because every time an organization needs a server, it's not, okay, I got to order a new server, I need to configure it, and I need to deliver it to the place where it needs to be used. Now all you do is create a new virtual machine. And you have templates for that. It takes 5 to 10 minutes rather than 3 to 4 weeks. So your businesses, if you're in IT, your businesses really like you a lot more too. Or you can just tell them it still takes 3 weeks and get it to them in 10 minutes and then go take a lunch break or something. Financial energy, human energy, again, 33% reduction in routine administration time. So this is when we survey our customers and tell you what does it take you, what has changed now that you've gone to a virtual environment over the physical environment, and things are just a lot easier to do. So I'd encourage you guys to check out all the vSphere sessions so you can see exactly what changes in terms of how you manage a virtual server as opposed to a physical server. And the reduction in time is just amazing. You're just playing with a piece of software rather than having to get in and configure all the hardware every time an organization wants something new. And then the Earth's energy, or what I would just say is natural resources, up to 80% reduction in data center energy costs. So you're not maintaining this huge farm of servers anymore. You're consolidating to a smaller number of servers, each running a larger number of applications. So how does this all look? Well, you got the traditional view, right, where you have Exchange on one system with Windows there and its own hardware, Oracle database on its own hardware, its own operating system, SAP, Siebel, all on their own hardware in separate siloed data centers or servers. What happens is as you maintain a migration to a virtualization infrastructure, you put the virtualization layer in between the applications and the operating system to manage communication with the hardware. But that's just the start, because as you create a virtual infrastructure, what you're actually doing is taking those physical components of the data center and pooling them into a giant computer. So instead of looking at things as separate physical components, you say, I've got this pool of resources, this pool of networking, pool of CPU, pool of storage, a pool of networking capacity, and these applications are going to use it on an as-needed basis. And then it gets really good when you start to be able to charge back to organizations and say, well, you use this amount of computing power, this is what I'm going to bill you for usage there, rather than having really no idea about what people are using. So this is getting to the utility model. And that's how virtualization starts out small. You consolidate a few servers, then you load balance things for high availability, and then you start moving to a virtual infrastructure where everything's pooled. And it's a utility. It's like electricity, it's like phone, it's like that, where at some point in the future, you're going to have a private cloud where everything's managed as a centrally used resource, and people are billed only for what they use. And the applications are developed so that they know they're virtualized, and they can actually make modifications to their own structure, to their own resources, to make sure that they meet the service level agreements that have been imposed on them. So if they need another CPU, the application can actually spin up its own virtual CPU. If it needs more memory, it will do it on its own. So we're getting there, and you'll hear a lot about that tomorrow in Steve Harrett's keynote. So this is how it works. And then the applications just work on top of the virtual infrastructure. You've got distributed resource scheduler, which is a load balancer, meaning if Exchange wasn't getting enough resources on a specific server, the DRS would know that, and it could automatically move Exchange to another server to ensure that it met its SLA. Distributed power management, another very cool feature that builds on top of DRS that says at night or during low periods of activity that you can actually consolidate the applications, the virtual machines that are running on a smaller number of servers, and turn off or put into sleep mode the servers that aren't necessary. And then when in the morning when people come to work or when a store opens or something like that, those sleeping servers can be turned back on and applications move back onto them. Another way to enable you to cut power costs even further. vMotion, as I said, that's live migration of a single virtual machine to another virtual machine, or to another server. With 4.1, our most recent release, you can actually do 8 of those at a time. So as people have higher and higher consolidation ratios on 2 servers, and if you wanted to perform maintenance on a specific physical server, and you want to migrate 24 applications, you'd only have 3 rounds of vMotion to go to get all the applications off of that single server and onto another server in that virtualized cluster. So it's a very quick, effective way to move an application from one server to another with no downtime. And you can do that with the storage files now, too. So if you've got storage files associated with a specific virtual machine or with an application on a specific LUN, you want to perform maintenance on those physical components, you can vMotion or storage vMotion those data files to another LUN, another storage device, with no downtime or interruption in performance to the end user. So you're really looking at things as a pool of resources. The vNetwork distributed switch, that enables you to manage your networking connections, your NICs, in a single fashion rather than individual NICs. So again, pooling things. And vShield zones, we have a number of announcements around our security products this coming up in the next couple days. But you'll see we're really expanding this to ensure that we're not only virtualizing the operating system or the server, the hardware, but we're also we're virtualizing the other components of the data center, because we want to make sure that your security is also virtualized so that you don't have to segment applications in a physical manner, but you can actually create DMZs or other zones of security within the virtual data center rather than among physical servers. Again, enabling you to further pool the resources into a single computing cloud rather than having very separate, siloed physical infrastructures. So reduce complexity. And so what happens? You become an efficient and resilient private cloud. So if you hear that term thrown around quite a bit at VMworld this year, the private cloud is your internal data center fully virtualized. I guess we would have called that a fully virtual infrastructure at one point. Now it's a private cloud. What it means is that your networking, your computing, your storage is virtualized, and you do look at those resources as a single pool of computing power. And you can really put any kind of workload on this, from server workloads to desktops, anything. And it enables fault tolerance, self-optimizing, applications built on like our Spring framework can be utilized or optimized for the virtual environment, and again, can maintain themselves in a lot of ways by adding on functionality or resources when they need them. So that's the term private cloud. So how do you get started, right? You guys are probably wondering, this is kind of interesting. Let me get my hands on it and figure out how I can start to get to know how to virtualize my own internal infrastructure. Well, what I'd recommend is that you guys go download vSphere Hypervisor. Now, vSphere Hypervisor is a free version, a single server version of our ESXi hypervisor architecture. So all this does is enable you to create virtual machines on one server, and you can run enterprise workloads. You can do whatever you want. It's the same enterprise technology that you would get were you to purchase one of our more enterprise vSphere editions, but it's just limited to a single server. So you can't centrally manage it. You can't create a cluster of ESXi or vSphere hypervisor hosts and migrate applications between them, but it will give you the full functionality that you would require to run enterprise workloads. In fact, it's actually very stable, very secure, and some of our customers actually just run a lot of their infrastructure on this, which benefits them, I guess. So it partitions a single server. It's plug and play, OS independent. You can run anything on it. It's a simple download from VMware.com. The good thing about it is it is fully performant. One thing that VMware has strived to do is to make sure that the virtualization infrastructure is never the bottleneck, that any application that you want to run, any application you want to virtualize, is fully within the bounds of our capacity. So you see 95% of applications in terms of CPU, memory, network, and IOPS. 1 to 2 CPUs, about 4 gig of memory required, 2.4 megabytes, and about 100% at peak IOPS, or 100 IOPS at peak. Well, ESXi 4.0, and this is the same hypervisor you would get for free as part of the vSphere hypervisor download. 8 vCPUs, 256 gig per VM, 30 gigabytes a second, and 300,000 IOPS. So it's fully able to support almost any application right now. And that's why we're seeing a lot of organizations migrate their tier 1 or mission-critical applications into a virtual environment, because they're confident that those applications are going to be fully supported, even during peak loads by our hypervisor. So this is what you would get as part of the free download. Hardware requirements for ESXi, pretty straightforward, single socket, dual core. Memory, 2 gig, ideal is 8 gig, of course. Storage, local storage, and you can use shared storage with this as well. So pretty straightforward. Download it, put it on any one of your standard servers that you've got in your environment. And again, I'll make these slides available to you, and this is also available online in case you do want to run out and download this. And you can do it while you're here. It's a very simple setup. And you could probably pick it up at the booth. At one time, we did offer or hand out ESXi on a zip drive or on a thumb drive. So they may have those at the booth if you wanted to pick one up there too. It's very quick. Just turn on the application or turn on the server. It will boot into the hypervisor. You configure an admin password. You can create a network configuration if you want to. I'd recommend that. And then you connect via the vSphere client. Now, the vSphere client is a free download. It's very Windows-like in its appearance. And you just create virtual machines from that. You can monitor virtual machine performance, change the configurations real-time of the virtual machine. And how do you create virtual machines? Well, here you interact with the virtual machines the same way you would a physical server, only through this interface here in the vSphere client. So it looks exactly like you would in a physical environment, although now, of course, it's fully virtualized. So how do you get started creating virtual machines? A number of ways to do that. One, you can use the VMware Converter, and that will automatically convert a physical environment into a virtual machine. So it's a good way to start maybe with some test and dev environments or some tier 3 applications. You can convert that. And of course, the physical environment still remains, so there is no risk in converting it. But now you have a virtual environment, and you can play with that and figure out how it could best perform or how you can best manage that on ESXi. You can also create them from scratch, of course. You deploy the operating system and deploy the applications the same way you would in any physical environment. Or you can import a virtual appliance. And I haven't used that term yet, but virtual appliance is a self-contained virtual machine that comes prepackaged with an application and an operating system. So we're hoping that a lot of organizations will move to packaging their applications this way, because it would make life a lot simpler if ISVs would just package the operating system with the package the application with the operating system, and you just plug it into a virtual environment, and then it works. And you can download a lot of these things. There are thousands of them available on the virtual appliance marketplace on VMware.com. And that's just a pre-configured virtual machine. Plug it into this ESXi environment and start playing with it and modifying it at will. You can manage individual VMs here, same kind of construct as you would in a physical environment. Power them on and off, suspend, take snapshots. That's the kind of thing that's interesting, is you can just copy the server, the virtual machine, create templates, create snapshots. If you're in an environment where you're updating or upgrading an operating system or applying a patch to a specific application, you can take a snapshot really quickly in the virtual environment, apply that patch, and then see if it's going to work. There's no attempt to try to roll back or uninstall those things. It's much more easy, much quicker in a virtual environment. You can monitor the individual VMs, so you can see what resources they're using, same way as you would in a physical environment. Monitor the hardware health of the physical server. So you manage both the virtual machines, their operating systems, their applications, and the physical components of the server in that same console. And then what's very good about the vSphere Hypervisor is, as it does contain the same enterprise technology that we offer as part of vSphere, is that you can upgrade it really quickly. It's just a license key upgrade. So what you would do is you deploy vSphere Hypervisor for free, single server partitioning, become comfortable that ESXi is a stable enterprise architecture, and then you can upgrade to vSphere 4.1, some of our kits or additions, to enable the pooling of resources, to enable the creation of clusters, to enable vMotion, the high availability, disaster recovery, automatic load balancing, power management, and things like that to create your virtual infrastructure. So there's no need to rip out the free version of ESXi and migrate and redo everything to get to vSphere 4.1, but it's actually a very seamless transition. It's a license file change. So all you do is deploy ESXi in each host. You'd add vCenter, which is our centralized management console that manages the pools, manages the clusters, and then you upgrade the license file once you receive those keys. And then you end up with a complete virtualization platform, right? So that's when you get to enable or realize all the benefits that virtualization has to offer. You'll see from vSphere 4.1, we have two different types of services as we call them out: infrastructure services and application services. Infrastructure is the pooling of the compute, storage, and network power into a seamless computer. So it's the giant computer, it's the software mainframe, it's the private cloud. So your computing power, your memory management, your DRS is load balancing. Storage, you got thin provisioning, which means that you can create the virtual machines with the minimum amount of storage required. And as the storage is expanded, or as storage requirements increase for that application or that virtual machine, the disks will grow. So you don't have to over-provision storage. It's another way to cut costs or cut capital costs. And you don't have any impact to performance for creating those thin provision disks. Storage I/O control, very interesting functionality where you create VIP virtual machines, so to speak. So if you've got 10 virtual machines on a cluster, and one of those virtual machines is the VIP and it can never have interrupted access to the storage resources, you designate that one as the VIP, and then if there is ever contention for access to storage resources, that VIP virtual machine will have priority access. So it will get in that red carpet lane at United and be able to board early. So that's storage I/O control. For network, we have the same thing. So network I/O control, right now you designate a specific flow type as being the VIP, and then if there is ever contention for network resources, that priority network flow type has priority access. So again, it's just making sure that your data center is completely automated, and it's more a utility than separate servers. And then the application services are all about making applications perform better in a virtual environment than they ever would in a physical environment. So about availability, we've talked a little bit about that, but vMotion, storage vMotion, migration of virtual machines from one server to another without any impact, without any downtime. High availability. In the event of an unexpected server failure, the applications will restart on another server within the cluster. That application will go down with the physical server, but instead of having to wait for that physical server to be brought up before the application is restarted, that application is automatically restarted on another server that is available within that virtual cluster. So really reducing the amount of downtime. Data recovery, enabling backup and restoration of data that may be lost. Fault tolerance, that's the shadow virtual machine that enables no downtime in the event of an unexpected server failure. Now, it does take a little bit more resources because you're running two virtual machines instead of one, but for those applications where you cannot tolerate any downtime, no data loss, it's a very good example, or a very good application to use. Security, again, we're working to virtualize security at all touch points, so you can secure the virtual machine, you can secure the application among a number of virtual machines, and you can secure the entire virtual data center all virtually now. And you can create your own zones of security in a virtual environment rather than in a physical environment. So if you've got two different tiers, those applications can live in and amongst each other in a single cluster, but the security designation will live on with that specific application no matter where it runs. And then scalability, of course, I showed you the scalability numbers for the hypervisor. We're just ensuring that the virtualization infrastructure is never the bottleneck, that any application, anything our customers want to throw at it will be fully supported and will run in a virtual environment. So how much does this stuff cost once you move past vSphere Hypervisor? We've really worked to provide a broad range of solutions that each meet the requirements of different customers. So you'll see our Essentials and Essentials Plus bundles, very cheap on a per CPU basis. Everything is still licensed per CPU in the vSphere world. These are 3 server, 2 CPU each bundles that enable a lot of functionality for the SMB, enables them to get started. Standard, Advanced, Enterprise, Enterprise Plus are the more, enterprise level virtualization packages, but each one of those is also sought by SMBs because it does provide a fully scalable, centrally managed virtualization infrastructure. And if you wanted something like, here's a breakdown of all the solutions and their functionality. Again, this is all available online as well. But if I had to put a tag on each one of those, standard, again, it does have vMotion, so you have the live migration, but it's for basic server consolidation. Advanced has the fault tolerance, so if you wanted zero downtime in the event of a server failure, you go with Advanced. Enterprise, Enterprise and Enterprise Plus are really the foundation of the private cloud. That's when you get to the higher level functionality that enables you to pool your resources, centrally manage everything as a utility, and then start to charge back to organizations only for the amount of resources that they're using. It gets very interesting when you start using this because there's a lot of great functionality, a lot of benefits to deploying things in that manner. Few vSphere features. I went through a lot of these. vMotion, that's live migration. Distributed power management, that's where you can turn off servers and when they're not needed and consolidate the workloads on a smaller cluster. Data recovery, again, a way to back up and recover data. Should there be a data loss, you can do that all in the virtual infrastructure rather than with separate hardware. And then fault tolerance, that's the ability to have zero downtime in the event of a server failure. There are other things that you can buy in addition to vSphere. Site Recovery Manager, this has been a very popular solution for a lot of our customers who are already deploying a private cloud because it enables disaster recovery workloads to be automated, simplified, and tested. I mean, most people, they like to get around to testing their disaster recovery plan, but the only time it really is tested is when you have a disaster. Here in the SRM world, you can have Site Recovery Manager test that for you and ensure that you will be up at a site that's obviously not affected by the disaster in a shorter period of time. Desktop virtualization. I encourage all you guys to go check out one of the sessions on desktop virtualization that'll be shown this conference. A lot of things going to be announced tomorrow regarding desktop virtualization. So a lot of movement forward in terms of technology, use cases. A lot of customers are really starting to look at how we can virtualize our desktops and even intermingle the desktops with the server virtualization infrastructure. So you're looking at desktops, servers, server applications, user applications, whatever device they want to use, and you're looking at that as all a single pool of resources, not a server and desktop world. It's all one world together now. Cloud computing, the logical extension, that's the way we're looking at things, is that you create a private cloud internally by pooling all your resources using vSphere, and then if you want to, you can logically and evolutionarily move to a public cloud with some or all of your applications. But what we're enabling you is to use vSphere internally, create that private cloud, look at things as a utility, migrate applications to a public cloud that is probably also standardizing on vSphere so that you're able to leverage your existing investments. Because current cloud solutions require you to fully recreate or rewrite your applications on their infrastructure in order to use them, and then you're kind of locked into their solution. What we're enabling you to do is, if you standardize on vSphere internally, migrate your applications to an external service provider in the cloud, and then if you don't like that service, you can move it to another service, but you're using your existing applications, the existing workloads. Everything is standardized and simplified across all these different solutions. So you create a hybrid cloud, if you want to, as well, to enable you to leverage internal resources and external resources and manage them separately or centrally. So that's the vision you're going to hear a lot about tomorrow. So in summary, what is virtualization? I know this is a lot of information, and hopefully it's getting you guys up to speed for all the other sessions you're going to get to. But it reduces costs, improves high availability, and simplifies operations. It starts to attack all the complexity of the IT environment that's been in existence ever since we've had the client-server model, I guess, and the server proliferation that resulted from that. ESXi, vSphere Hypervisor, high-performance enterprise-class hypervisor that you can download today. It's very simple to be up and running, to play around, become comfortable with the technology, run real applications, real workloads on the free version, and then quickly upgrade to vSphere Enterprise Edition or one of the other editions if you want to achieve a private cloud or any of the other benefits of virtualization. So I'd plan your upgrade. I'll move to ESXi. As I said, if you're an existing customer running ESX, we're not going to support ESX past this next release. So I would move to ESXi as soon as possible. And with that, I'll take any questions you guys have.